Hello and welcome to the SaturdayMP show, episode number 26, being recorded January 2nd, 2024. I'm your host, Chris, and today's episode, as you can probably tell, is going to be a little different than other ones. Today we're going to actually play a game called the Human Resource Machine, and so this game is a game about almost like assembly level programming, and I was able to get it for free over the holidays thanks to the Epic Game Store. They had it was free for one day, and so I was able to pick it up. I've actually gotten this game for some other people, some kids back in the day. It was part of a Humble Bundle, and that were interested in programming, so I bought it for like my daughter and a friend of the family. So I played a little bit before then, but I spent all of the holidays playing it a bunch. And then someone asked a question about it over the holidays, and I thought, well, what the heck? Someone asked a question about it in the Dev Edmonton Slack channel. Let's make a video about it. So that's what we're going to do today. So thank you very much for the question, and kind of there's my thoughts about it. And kind of researching this is also a sequel called 7 Billion Humans. So I think I'll probably get that while it's on sale, because it's like $5 or $6 or something right now, at least on Steam. You could probably get on Epic and other places on sale. So yeah, so I guess I should also mention, I didn't mention this at the beginning, that I'm your host, Chris. And if you have a question that you want me to answer on the SaturdayMP show, the show where we try to help you ship secure, high-quality software faster, you can put it in the comments, the YouTube comments below. You can send an email to ask@SaturdayMP, ask@SaturdayMP.com, or you can post in the Dev Edmonton Slack channel. So, and yeah, I'm happy to answer questions and create a video about it. So I guess we should just get this started. Let's see what happens here. All right, so I've already played a bunch of it. So I think what I'm going to do for this video is, for those that haven't watched any of these videos before, I just record them live, very little editing, little to no editing. So I think for this game, I'm just going to, I've played a bit, so I'm not, like, look how high up you can go. Oh, I guess I'm about halfway. We'll do one or two. Like, I noticed too when I was preparing for this video that I didn't get both these little green dots here to kind of optimize. So for each one of these challenges, you'll do it in the least amount of instructions, but you also should try to do it in the least amount of steps. And sometimes those are not, you can't complete in the least amount of steps and the least amount of instructions. So I will kind of get to that in a minute, but yeah, so maybe I'll show some of these easier ones just to show the basics of the game. Then I'll jump back up to one of the ones I'm trying to solve. And when you get to these branches here, this is kind of the normal path on the right here, and this one on the left is kind of the harder ones. Oh yes, yeah, I only have one dot here. I haven't finished Fibonacci yet, so maybe we'll explore some of these harder ones, and we'll see how interesting a video this gets. All right, so let's go. Let's just go to this busy mailroom here. All right, so here. Oh, excuse me. Here's the busy mailroom. Grab a drink here. So, all right. Oh, sorry, I did pause it there because throat's a little gunked up. I think I have a little bit of a post-Christmas cold. Oh, I guess I should say Happy New Year too to people. I hope you had a great. This is January 2nd when I'm recording this, so I hope you had a great holiday break, and 2024 is off to a great start. I'm excited for 2024. But anyway, so we have the busy mailroom. So on the way this game works is you're this little guy over here. Hopefully my mouse pointer is showing up. And then you can click the person again. Like they'll give you some instructions. And you give an example. Right, and so in these simple examples, you're just supposed to take the things from the in and put it in the out. And they're kind of introducing these instructions. It's very low-level computers, so it's almost like you're programming in assembly, and later on you'll have like little registers and very basic instructions like adding and subtracting. But there's no if statements, there's no functions, at least not that I've run into. There's no What are some of the other ones that would be right? There's no like high level primitives that you can use. It's all very low level stuff. So in this case, we did. Where's our optimization? Oh, we didn't. The speed challenge. It took 30 steps on average. Okay, so we did 3 commands. So this is the 3 commands we had here before. So we had inbox, outbox, and then we go back to the beginning and do it. So let's just. So if we watch what they do, we can even step through it here. The person's going to go. Your little guy will pick the thing up from the inbox. Your little person there. And they'll follow this instruction too, put it in the outbox, and then go back to the beginning. And here we just watch them do it. Boom. And then we can even speed up the thing. Okay, so that's done. So my size challenge is 3, but the speed challenge in 25 or fewer steps. I don't know how to... Huh. That's interesting. I don't know how to... Do I just unroll this loop? Is it just inbox, outbox, inbox, outbox? Until it's done? How would I do this in less steps? Like, I guess I... Do I just do like this? Like unroll the loop? Oh, let's see. Because then that way we have one less jump. Yeah, okay, okay. So this is where the size challenge, right? Because now we can use 5 commands. So let's just go back here. So this is 1, 2, 3, 4, 5. And the steps is every time the little arrow goes there. Oh. Right, so every time I click like there, that's another step that was used. So, okay, so some of the, at least in the beginning, solving some of the problems with the optimizations, you couldn't use the same commands anymore. Okay, so that's basically how this works. These ones are all letters, other ones will be numbers. Oh yeah, okay, good. I got 2 greens there now. So maybe I'll just show a quick, what is this? So this one, I think we want to preserve zeros. Send only zeros to the outbox. So you can see, oh yeah, so I have the first on the tab, you can have multiple programs here. On the first tab, this is usually the one I, just kind of my initial shot at it, and I usually end up solving the optimization for the size. Well, it depends. Sometimes it's the size, sometimes it's the speed. Usually it's solve it for one, and then I use the other tab to optimize it. So I don't know. This one's 5 commands, this one's 6. So this one must be the, yeah, 5 commands and 25 steps. So in this case, we're going to, oh, we're not even using, see, there's all these registers we can use on the floor. Here we can put things on there, but yeah, we're just grabbing from the inbox. If it's 0, put it to the outbox. If it's not 0, then go back and get the next one. Right, and then this one, we save some steps by, so this is something I got to wrap my head around for assembly level programming. Sometimes you'll put the end result that you want at the beginning of your program and just kind of skip over it at first. And that'll actually save you some steps in the long run, I've noticed sometimes. So there's unrolling loops, and there's also putting the end result at the beginning of your program. So, yeah, okay. So that's how, I guess we could just watch this real quick. We just boom, boom, boom. There. So, okay. So let's go back here. Let's try and solve a harder one. So maybe what I'll do is I'll just do this littlest number, because these ones on the right aren't as hard, although I'm not super smart. So this is live, so hopefully this won't be me frustratingly trying to figure it out. And then maybe I'll either try the Fibonacci Visitor and try to I can't remember what optimization I got, and try to get the other one. And the mod module. So mod is kind of, does it actually divide by the number or not? So that's an interesting one. So you're trying to do these really complicated, well, somewhat complicated math operations, but all you have is registers and basically add and subtract. So, all right, let's see the littlest number. All right, to reduce our carbon footprint, management is requesting the smallest numbers only. Right, yeah, so it's kind of the whole idea is like corporate drones and blah, 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 boring office work. So you can see here we got a bunch of commands that we can use. And these are just, you can add, this is just a comment you can put. I have to write with the mouse, which is really hard, so we can use those if we need to. Okay, so for each zero terminated string in the inbox. Oh, right, so these are zero terminated strings. So basically a zero terminated string is from C. You read the way strings are handled in C, and I think in other languages under the hood, is you'll read letters until you get to a null or zero, where there's a null or a zero at the end of the string. And that basically means the end of the string. That means stop reading. That's how the computer knows that that's the end of a string. So in this case, we have 7, 15, and 2, and then 0. So this 7, 15, 2, and 0 is one string. And then we can't see the other ones, but I think it'll also give me an example. Right, so if my inbox is this, so this is one string, 7, 15, 2, and 0. So 0 is not actually part of the string, so we kind of ignore that number. So we want these three here, and the smallest one is 2, so it ends up down there. And then we got 10, 10, 5, 4, 0. So 4 is the smallest, it goes there. And then all these other numbers, 45 is the smallest. So I don't know if you can have just a 0 for the string. I'm going to assume for this exercise that we're not just going to have 0. But that might be part of the input, like where your string, like instead of a 7 here, if it's just a 0 right off the bat. That was in the previous one, but I don't know if that'll happen in this one. So for now, we'll ignore that, I think. So now, this is where I have to think, because right now there's no real way, there's no like comparison, like is one smaller number smaller than the other. So this is kind of an interesting way to show you how, when you have what the computer does under the hood. When you do like a complex comparison operation, it has to use some of the basic commands that are at the computer at the hardware level, interpret what you have into those basic commands. That's what a compiler basically does. It takes your complex statements and converts it into this simplified computer code. It's a surprising amount of steps, but the computer just does it so fast that it doesn't really matter. So, okay, but anyway, so we'll start. So we'll grab this inbox. How do we want to do this? So we'll take the first number, we'll put it into 0. We'll take the second number, put it into 1. And then we'll compare the two by subtracting them. Right, so we'll compare the two by subtracting. And then we can decide if it's negative, we can figure out which one's bigger than the other. If it's 0, they're the same, doesn't matter. So if it's negative, I can never remember. We have to take the one on the left or the right. And then we'll save that. I think we'll put that as the output is 3. So maybe what I'll do is I'll put some comments here. So this is our... Alright, let's see how well I can draw here. This is the lowest. Lowest. Oh yeah, nailed it. Okay. That's our current lowest, so we'll just store that there. Well, no, wait, okay, so... Oh, can I copy? What does this do? Oh, that just undoes it. No! Actually, we could probably only do this with 2 registers. Because we'll take the 7, put it here. 15, put it here. We'll compare the two, and then we'll keep the lowest in the 0. And then we'll put the next one back in 1. Compare the two. Keep the lowest in 0. Okay, so we only need 2. So let's just delete that. And we'll put this one as, this is our lowest. But we need to do a little bit of setup. We don't know it's the lowest when we first, and this is the compare. Compare. Well, I don't think that did come out very well. Okay, so we're gonna grab from the inbox. So the first time we just need to initialize the lowest in the comparison. So we'll grab from the inbox and we'll put it in here. We'll grab from the inbox and we'll put it in here. So when we do the jump, like we'll come back to here because we don't need to initialize the lowest one again. So we'll compare the two, and then we have, I guess I could just show this in action here. Let's just show this here. I'll do it slow so people can see. So it picks it up, puts it there, picks it up, puts it there, and then they're going to complain because that's the end of that. But what we want to do is we want to subtract. So if you notice, the still kind of in this fellow's hand was the one, in this case, the 9, we picked it up and then we threw it away. And then we picked up 12, put it here, but we still have 12 in our hand. So we can subtract 12 from whatever's in 0. Right? I think that's what we can do. So 9, got rid of that. 12, boom, 3. So in this case, because the number is positive, we know the one on the right is larger than the one on the left because 3 is greater. So we don't have to do anything because the 9 here is the lowest. So this is okay. If it was negative, okay, so we have to build our little thing like this. If it was negative, we'd have to jump down here. And then we have to move the comparison one to the lowest one. So we have to copy from compare, and then copy to, because that's our new lowest. And then we need to jump back up to here. So we can always optimize this for steps and stuff later. Because the other thing we're not checking for 0 yet. We're just kind of building our initial little problem here. So let's see. I'm just going to speed this up. So 3 goes in the lowest. That's our setup. Then we go grab the 15. It goes there. 12. It's not negative, so 3 is still in the lowest. That's good. And we jump back up to the top here. Well, not the top, not our initialization, but the top of our loop. And we'll go grab the next one, we'll put it there. So now we got -2, so it's negative. So now we need to adjust these two. Yeah, so we put the 1 there. Okay. And then it's going to, we're not putting anything in the outbox or anything, but now we need to add the 0 compare, because we're going to grab 0. And we should actually check if this is 0. If it's 0, then grab the lowest. Okay, let's add that now. All right, so inbox, if it's 0, what do we want to do if it's 0? I think we just want to do I jump it all the way down? Yeah, it's probably inefficient, but okay. Okay, we'll just do it like this for now, because it's the way my brain works. Put it... No, we don't want to put that one to the outbox. We want to copy from the lowest and put that in the outbox, and then we want to start doing our loop all over again. So I think this will work. Copy to lowest, inbox. If it's 0, we go here. Jump if 0. Copy from lowest, outbox, go back to the beginning. If it's not 0, compare them. I don't know, let's see. So let's speed this up a little bit. 4, 10, 6. So that should stay as is, which is good. We have 1. 1 is less than 4. So we should switch the 2. Yep, good. And now we should go grab the 0, which we'll throw, which we don't care about. Grab the 1, and there we go. All right. I'm just going to let this thing run now. Oh, here, I can let it run slower, I guess, if people want to see. I wonder if oh, okay, that's a problem. I didn't set that up properly. I do have to reinitialize this again. So when I'm done, I don't want to jump to here. I actually want to jump all the way up to here, I think. Okay, let's watch this go. So that's okay. Boom. Put 2 over there, great. 0, take the 2 over there, boom. Now I need to initialize this with 15 and 16, so 15 can go there. Okay, there we go. And then 1 should end up in the lowest. Alright, oh, this one, big numbers for some reason. Not that that should matter. $83, so this should say 39. Yep, great. 67, so that should stay. That should stay. And the last one. Oh, done like dinner, great. Alright, so... oh, we didn't get the command size. Or the speed challenge. Okay, so we're 1 command away. Probably we could optimize a jump or something. Let's see if we can get down to 1 command. Oh, some interesting things too. You can actually copy this and then paste it here if you want. You can also sorry, let me just let me clean up Notepad here. Alright, so if we copy this in the game and I put it into Notepad, there, you can see it actually writes it out like kind of like assembly language, right? There's your label that you're jumping to. So we're going to go inbox, copy to register 0. There's a B label, a C label. And we'll do inbox. We'll jump to E, jump Z to jump if 0, jump to E, copy to register 1, subtract from 0, jump if negative to label D. Otherwise, jump to C, back up here. So, yeah, if you want to keep your thing there. And then his labels, I'm assuming this is the label. Supposed to be some way of storing that image label that I wrote. So let's just put that over there for now. Okay, so I like to copy that just in case I screw this up somehow. Because I want to get rid of a command here. I'm sure one of these jumps can go away. I just have to figure out which one. So here. So we grab from the inbox, we copy to the lowest, because it's currently lowest, we have no idea. Grab from the inbox. If it's 0, we would just take the lowest. Otherwise, we'll copy to the compare. Subtract the 2. If it's negative, we adjust the lowest. I guess we wouldn't even really, like, if we really were short on registers, we could just subtract and then re-add that number there before we shove it into the lowest. But with that, so we don't have to do copy to the compare. Is that what we could do? If we copy to the compare, Instead of doing that, we would just subtract the lowest, but then we'd have an add. Oh, maybe. Okay, so if I get rid of this, if it's negative, we keep all these. I'm sure there's a way to optimize these jumps too, but if it's negative, we would want to add, re-add it, and then copy it in there. All right, is that 13 commands? What was our optimization? 13 commands. Oh, is that going to work? Let's see. Oh yeah, there we go. That looks pretty. Oh no. Okay, yeah. Aha! All right, let's speed this up. Let's see if it works. Hey, there we go. We got rid of a command. Oh, good for us. Oh, and we did the speed challenge too. We could probably clean this up more, but I think if I make both of those, I'm pretty happy. Yeah, I'm sure there's a way that all these jumps could be cleaned up a bit. Like, we copy this to the lowest. We don't even need to. We can actually get rid of this command, I think, too. Is there something that jump? Oh no, we need this if we jump from 0. Because this copy to the lowest, we would already have it stored there. But this one, okay, that's good enough. All right, so there, we completed the puzzle. We did the littlest number. So maybe I'll go back to the Fibonacci one here. Yeah, let's try the Fibonacci one. Let's see if I can optimize this one a little bit more. All right, so I have my initial program here. Oh, this one's pretty long. Oh, I guess here we can. Right, so these are the optional ones, and they are difficult. Looking for a golden spiral. Oh, they're doing the Fibonacci. Right. Alright, so the only thing we want in the inbox is the full Fibonacci sequence up to but not exceeding that value. For example, if the inbox is 10, the outbox should be 1, 1, 2, 3, 5, 8. So you can Google it. So there, it's got it down there. So, which optimization do we have? Oh, we did the speed one. Wow, we did 109 steps and 756 steps. But we need to get it down to 19 commands. So I can't remember. Oh yeah, we're down to 21 commands here. What's this one? 26 commands. Woof. So we could just see this in action here. You can. Or how did I? Maybe let's just do this a little slower. How did I solve this again? So I put the value there. I grab 0. Right, because we kind of assume that the first. We don't have to worry. We're going to assume that the number we get from the inbox is at least 2 or greater. So this part here, this is just the initialization where we put 1 and 1 in the outbox. And then what I did is I based this loop here was just set up. So I guess I never labeled these. The 0 was like the first letter. The 1 was the second letter, the 2 that we were going to add. Yeah, so we would just set it up like that. So 3 would go there. Is 3 less than 8? It is. So output. Oh yeah, I would adjust I would copy 2 to here, 3 to there, so that we're set up for the next round of the Fibonacci sequence, and then put 3 in the outbox. And then it's 5 less than 8, yep. Yeah, and now 3, so 8. Oh, this one had a special case, right? Because there was negative and jump if 0, because I wish it was like if 0 or negative, but this only jump if 0, jump if negative, which was super annoying. Because we actually need to output this 8 up to, but not exceeding. So we actually need to output the 8. So we would throw the 8 out there and then be done with it. Okay. And then we just repeat it for the next one. Oh, here. Why don't we just play it in slow-mo? Maybe a little faster. So 5 is 0. 5 goes out there. Now we reset up for the next go. So I think this one made the step challenge, but it didn't meet the number of commands. So 13 is less, so 13 should go out there, and then 21 is greater. We're all done. Yeah, so this has made the speed challenge, or size challenge. So size challenge is trying to do here. And one of my hacks was to just take this initial 0 input and bump it to 1 right away and just use that. So, boom, because we don't care about 0. And then, so that's like a first thing we do. And then this is the setup for our Fibonacci sequence where we get the inbox, we get the items, we set up 1 and 1. So there's kind of a wasted step right there because we already have 1 in our hand. So we add the 2, put the result, compare, it's less, so we're good. Right, and then we have to adjust so we get 1 and 2 for the next setup. Oh, and I haven't completed this, I need to. Alright, so I'm still working on this one. I have to get this down 2 more? Is that what I need? Jeez. So this is this logic here. Can I put a, how do I, okay, so we bumped that. Yeah, that's fine. So then we can take 1 out there. Inbox. So we got to save that initial value somewhere. Guess we can put labels on here. Let's just call this in, I guess, for our input. We'll just call this left. This is the right. And this one would be the sum of the current ones. So let's just call it that. Okay. So we copy from 9, which is now 1. So this is our setup. Let's put that here. Setup. And then this is our loop. Yeah, we got rid of the jump if 0 check. Well, we check it down here. Oh, we got to the end here. So that's the loop. We copy from the sum, throw it in the outbox, copy from the right, add it to the left, throw it in the sum. So I wonder if there's something where we can get rid of, like, oh, maybe like that previous one where we don't need to have the sum. We could just add it if we need to. Ooh, but as soon as I throw it in the outbox, it's gone. We could try doing it without a sum. So inbox, copy to 9, left, right. Ooh, okay, actually first thing I'm going to do is I'm going to copy this and throw it into my notepad here. Okay. And I have it just in case I screw this up. So if we get rid of the copy to sum. So this one's okay. So I don't need this copy from sum. Let's just gotta go to the outbox. Add to the left. So if we got rid of this copy to sum, if it's negative, it's not negative. So I'd have to put an add back in here. Like that. And then I go back up here, outbox. So if it's not negative, that means we're done with the. Alright, so if it is negative, we're not done. If it is negative, go all the way back up to the setup, which is throw that in the outbox, which is good. Grab the new inbox and do all the setup things. Are we down? Oh, we're down to 19. This might be it. Okay, if it is negative, we go to here. We want to copy. Oh, basically we have to adjust everything again. So I don't need to copy from sum. So this can go away. But when I get down to here, I still need to add this again. Jump if negative, go here. And then, oh wait, subtract. If it's not negative, then yeah, we're done. If it is negative, go here. Copy from R to L, and then I'll need to do an add here. Oh no, wait, I need that sum again. So the sum needs to end up in R, and the old value needs to end up in L. Can I just dump this into L? So I have 1, 1. I add them together, I get 2. I dump 2 in here. I want to dump 2 in the R. But I have to remember... Okay, let's say I have 1, 2, and I need to get 3. So I have... boom, boom, I get 3. Yeah, if I go back and forth, that's harder to do. I have to make one of these registers the lower one. So 3, I subtract it from the input. It's less than 9. If it's negative, which it's not, so then I re-add the input. Or sorry, it is negative. So I need to just set up for the next loop. I need to put R into L. Go be R into L, and then oh no, wait. I need to re-add them, and then R into L. So what's in my hand when I get here? This is subtraction of those two. Oh, this is 19 steps, so it's not going to work. Can I get away Fibonacci, which is 2 registers? I don't know if I can. Go here. Move this one into here. This is adding these two together. And then subtracting. If it's negative, we add it, go back up here. If it's not negative, put it in there. If it is negative, go down here. So I'm down to 18, so that's good. If it's negative here, do I add? Copy from R to L. Yeah, I think I need to. I think I'm going to need 3 registers no matter what. I don't think I can get rid of a register. Copy from R. Add to L. Subtract. Okay, so bump, boom, done. Setup. We write 1 to the outbox. We get the next one from the inbox. Oh, excuse me. Copy it here to the in. And then we set up, so we copy 1, because this will be 1 in 9. To the left and to the right. We still have 1 in our hand, so we'll write that 1 out there, so that's good. And then we want to... Right, we're going to outbox that, so then we have to get an R again, add it to L, do subtraction. If it's negative, that means we want to keep going in the loop. Okay, so it's negative. We need to... Yeah, we're going to need 3 because we got to... Oh, yeah, I don't think we can dance back and forth. Jump if negative. Oh, okay, so this, yeah, it's probably taking a little while. I wonder if people are finding this interesting or not. Subtract the inbox. Jump if negative. Copy from R, copy to L, copy to R. Oh, that one's pretty tricky. Okay, I'll have to think about how to do that. Maybe I'll just post a blog post or something. Let's see if we can solve an easier one. Let's do the mod or cumulative countdown. Let's end on a positive note. Let's do cumulative countdown. Okay. For each thing in the inbox, outbox the sum of itself plus all numbers down to 0. For example, if the inbox is 3, the outbox should be 6 because 3 plus 2 plus 1 equals 6. Oh, that's interesting. Okay. Sum of itself plus all numbers down to 0. Oh, okay. So, we have to grab this first one, 4. I think we're going to need 2 registers for the... I don't think we need 0. Like, is it better just to start at 0 and count up? Or I think we could just do subtraction for this. Three. Yeah, so we want 3 plus 2 plus 1. So we can grab the inbox. We can just shove that into, say, register 0. We can grab the next thing in the inbox. We can add it to register. Oh, no, we don't want to grab the next thing in the inbox. Whoops. We want to add... No. Yeah, so if it's 4, we need to bump it down 1. Okay, but bumping will actually, you can put it down here to see what the commands. We'll subtract 1 from the contents of the tile on the floor, the register, and it's also written back to the register or the floor and your hands. So I can't. I have to actually. I think I'm gonna need 2 registers for this. So let's do the setup there. So then we subtract this, or sorry, we bump this one, then we add the 2 of them. And then we have to write that to... Oh, we have to start the highest, right? So we have to actually write 3 out there right away. Okay. So 4. And then we need a 3. Oh, no, wait. Sorry. We only need... I screwed that up. Okay. For example, if the inbox is 3. Okay, so in our case, we want to read 4. So the 4 should be 6. It should be 10. Okay, so we can copy to 0. So 4 is there. Then we need to add 4 plus 3. So we also need to copy this to 1, I think. And then we need to add the, we need to bump the 1 on the left. And then we need to add the 2 together. So that'll give us 4 plus 3 is 7. And then we need to write that to 1. And so 7 is now in register 1. Then we need to bump register 0. And then we need to add to register 1 again. Okay, so. Alright, so I think we can. If it's 0. So if it's 0, we'll write to the outbox. Just have a jump here to start our program. And if it's not 0, then go here. I think that's what we want to do. Let's see. So, grabs the 4. Yeah, great. Okay, perfect. So we bump this. Add these two 7. Fantastic. Write that into 1. Yes. Bump that. Add these two 9. Write that there. Yes. 10. Oh. I need... How do I figure out if it's 0? Oh, my jump to 0 is in the wrong spot. Right, so we put 10 there. So okay, so a couple things to fix is this needs to go here. And because we just bumped this, we also need to copy from 1 before we outbox it. Okay, I think this will work. Let's see. So 3, so this should be 6. That's 5. That's great. Shove that in register 1. Hey, 6. There we go. Okay. Now we go here. This is 0. It's 0, so we get this guy right to the outbox. Great. Now we go back to the inbox and initialize our loop again. So 4 can go there. 4 can go there. Yes. 7. That can go in there. So what did we say 4 was? 4 should be 10, right? So 2. Yeah, that looks about right. 9. We'll throw 9 in there. Oh, we do have a 0 to start off the let's see if we handle the 0 case after this is done. So that's 0. We're going to screw up. We're going to have -1 here, I think. This is going to be a problem. Right, we're going to put 0 there. Great. Put 0 here. We just have an infinite loop now. Okay, we have to handle the special case of 0. Okay. Actually, I'm curious. What does it do if it gets an infinite loop? Does it just go forever? Is it going to eventually overflow? Like... Oh, okay. I'm not going to wait. Okay. So we need to check. So I guess we could just do this. If it's 0, just write to the outbox and go get the next one from the inbox. Okay. Let's see if that solves it. There we go. Hey, that was pretty good. Cool. Oh, we did both of them. All right. What are we, almost up to an hour? I think that's a great way to end the video. So yeah, basically there's a quick, I guess, review of human, maybe review. That's, yeah, if you're looking for a fun game to play that involves very low-level programming, I highly recommend the Human Resource Machine. And maybe if people are interested, maybe I'll take another crack at that Fibonacci Visitor, or maybe I'll just end up solving it on my own. I can show you what I did in a future video. So if you're interested in that, leave some comments below. If you thought this was interesting, leave some constructive comments. Yeah, or send an email to ask@SaturdayMP.com. And again, if you found this video useful, you can hit the like or subscribe buttons, all those things. Share it with a friend to help others find it. Yeah, if you found it boring or something, send me some constructive criticism to ask@SaturdayMP. And yeah, thanks to the people that made the Human Resource Machine. This is a really fun game. I got it for free, but you can buy it on sale right now on Steam and probably various other platforms. And yeah, if you don't buy it now, it's probably not on sale, but you can buy it at full price. And they also have a new game I want to check out. So here's, yeah, Tomorrow Corporation. So if you go to this thrilling sequel, they got 7 billion humans. So I think this one looks more like a little more high-level programming. Like I can see in the screenshot, there's if statements and stuff like that. So I'll probably buy this while it's on sale over the holidays here. And then, yeah, try it out. So yeah, thanks everyone for watching. I wish you all the best in 2024. And yeah, I wish you all the best in 2024 and hope to see you in future videos on the new year. Take care. All the best. Bye.